In this video, we'll talk about why LLMs hallucinate and what causes them. Let's do a quick recap. Tokens are locations. Attention shapes those locations based on context. Prediction picks the next token from a distribution. Training settled all of this, with millions of small nudges. So why does the model sometimes confidently say things that aren't true? Before we get into the technical side, let's look at a case where this happened in the news. A lawyer used ChatGPT to write a court brief. The brief cited 6 prior cases, none of which existed. The judge flagged the fakes. The lawyer went back to ChatGPT and asked it to confirm. ChatGPT insisted the cases were real multiple times. As you might expect, they were not. So, why does this happen? Every prompt produces a distribution over next tokens, every single one. The architecture has no I don't know mode and no way for the model to stay silent. It will always produce something. The only question is, what? Let's analyze 2 prompts. Who uploaded the first YouTube video in 2005? The geometry and attention bring up the most likely answer. The distribution peaks confidently on Jawed Karim, the actual founder who uploaded that first video. Now let's try something impossible. Same prompt, different year. Who uploaded the first YouTube video in 1945? YouTube didn't exist in 1945, so there's no real answer to this. But the geometry still produces a distribution, because that's all it can do. The peak is on a hallucinated name, Walter Jones, with about the same confidence as the prediction that was correct. The model does not know any answers. It just predicts the next token in the sequence, because the context isn't a phrase, it's a sequence of tokens. As we learned in the previous video, training optimized the model for one thing, to reduce loss, not truth. As you remember, loss is a measurement. It tells you whether a prediction matches the training data. There is nothing related to truth in any part of this process, not in the calculations, not in the model's understanding. There is no representation of truth in mathematics. And here's the deeper point. Even if every word of training data were verified true, hallucinations would still happen. Because of how the geometry settles, millions of training examples pull on every token. The position the token ends up in is a noisy average of all those pulls, not an exact match for any one of them. Training is a multi-dimensional tug-of-war. Many ropes, all pulling on the same token. Each rope is one training example. Different examples pull different ways. After millions of rounds, the token settles where the pulls balance. For tokens with consistent training signal, the pulls agree, and the position settles tight, a sharp, precise location, a clean answer. The model can recall accurately. For tokens with sparse or conflicting signal, the pulls disagree, and the position settles fuzzy, only an approximate sense of where the token lives. But no matter how a token settles, tight or fuzzy, the model uses it the same way, with the same confidence. Now the part most people miss. When the model produces a token, it does what's called a forward pass. It takes the prompt, runs it through the model end to end, and produces the next token. One direction, no second pass. It appends that token to the prompt and does another forward pass for the token after that, and so on. And a token can't be true or false. It's just a token. There is no backward step where the model goes back to check if what it generated was correct. From the inside, every answer is just a prediction of what comes next. There are some techniques to reduce hallucination, mostly by grounding the model with real data. A few things help. By using retrieval, we can give the model real text to ground on, tools let it look things up, or we can train it to be more willing to say, I don't know. But remember, these are mitigations, not fixes. The mechanism doesn't change. The model still doesn't know what it knows. Hallucination isn't a bug being patched out. It's the algorithm doing exactly what it was built to do, predict the next token, whether that token is true or invented lives outside the model. Next video, sampling how the distribution actually becomes a token.